Okay, so today I will be talking about the logic that I used to solve the next permutation problem. It is leetcode problem 31 if I'm not wrong. So yeah, today I'll be talking about the logic I used. The ultimate program that I'll have is like almost exactly the same as what Driver had in this video, but I think sort of got to it in a different way, and yeah, I just wanted to kind of document that for myself as well. So yeah, okay, so the problem is basically that you're given an array of some set of numbers. I think in that particular problem it said all the numbers are positive or something, whatever. Let's just say that they're all integers, okay? But really, the program that we're going to write, it doesn't matter whether it's an integer or a float or a what data type. As long as you can perform comparisons, it will work. So yeah, so let's just say something like 1, 2, 3 is given. Then the job of your program is to make the next permutation. So 1, 3, 2 would be what the program should return. So just based on this, we can write a simple function thing like this. So let's say next permutation, let's say v1. Maybe there's some room for improvement as well. So it will take an array, that's all, and it will return it. And the program we're gonna write will just do it in place. Okay, so yeah, okay, so yeah, it's gonna do this permutation thing in place. Now let us just start with a simpler problem. So clearly the reason why I think this problem is hard is or not hard, it's not like immediately obvious what to do, is at least for me, is that I immediately didn't have any, like I'm not used to finding the next permutation of something, right? Like how do you systematically go from one permutation to the next? I never thought about that question. So, and it doesn't seem like a very easy process of just swap, like always with the same kind of swap. It doesn't feel like a very easy thing. Like if we take something like the partitioning thing that we do in quicksort, it's a very like relatively simple thing. Okay, if it's below, go behind the partition. If it's more, then go in front of the partition. This is not some easy swap like that, right? This is kind of non-trivial. So let's just start with a simpler. So basically what I'm trying to say is we need to come up with a systematic way to go from one permutation to the next. Like how would you go about doing that? So to understand that, let's take an array with two numbers. Let's just say 1, 2. So what would you do for the next permutation? If you just had this, you'll swap it. So you'll just make it 2, 1. And then similarly, if you had to go from 2, 1 is the last permutation, right? So then when you come to the last, you just have to reverse the whole thing to get back to the original thing. So basically, if you have just two elements and they are in like the correct order, then what you have to do is swap the two, and if they're already swapped, then what you have to do is reverse the whole thing. So that's what you have to do. Like essentially cycle back to the start is what I'm saying. So this is what you do if you have 2. Now let's see what you have to do if we have 3. So let's say we have 1, 2, 3. Then how do you go to the next one? For the next one, you need to first just keep this one as it is, and then like swap these two. Essentially, kind of forget that this has 3 elements. Just imagine it has the last 2 elements, and then check if they're sorted. Like check if it's in the correct order. If it is, then swap it. And if it's not, so basically what I'm saying is, if you're given 1, 2, 3, you need to swap the last 2 to go here. Then after this, what you have to do, again swapping these 2 just brings you back to normal, right? So what you have to do is, from 1 you now need to put 2, and then you have to put the remaining in the correct order, right? So 1, 3. Then what you have to do is, again just keep 2 fixed, and then swap the remaining 2. Then again swapping doesn't go to the next one, so now you have to take the next element which is bigger than 2, which is 3, and then put the remaining back in the sorted order like this. And then now again swap the last 2, and for the next one just swapping it back doesn't make sense. So now you go to 3 and then the next thing after 3 is nothing, that's all. This is the last permutation, right? So we should have had 6 so far, 1, 2, 3, 4, 5, 6, perfect. Then what you do is just like reverse the whole array, you will come back to 1, 2, 3 and then you just cycle after that, right? So essentially what we are doing is, we are first seeing, if you have 3 elements, the way we are doing it is, we are seeing if this 2 and 3 is sorted, then we just need to flip it. If it's already flipped, then you go to this number, from these numbers pick the one which is just after 1 and then you put that in the start, and then for the remaining elements you need to keep it sorted, right? Like that will be the least combination, smallest thing. Then after that again this is now sorted, so to go to the next thing you have to like flip it, so you flipped it, then you keep 2, then again now this is, you don't need to flip this again, so take the thing which is just bigger than 2, which is 3 and so on, right? So I hope this is like understandable. So now let's go one step higher. So let's say we have 4, so 1, 2, 3, 4. So now let's kind of think in a systematic way, right? So instead of looking at the whole thing, what we are basically doing is we're looking at the last 2 first. The first thing we do is look at the last 2. If the last 2 are sorted, then all you have to do is flip it. So you will now do 1, 2, 4, 3. Then now if you need to find the next permutation of this, look at the last 2 again, it's already flipped. So what you have to do is go here, find the element which is just bigger than this. So what is just bigger than 2? 3. So you need to put 3 here, and then the remaining 2 and 4 you have to put it in the sorted order. Then now again look at the last 2, it's already sorted, so you need to flip it, so that will give you 1, 2. So do you see what's basically happening? We are essentially like, now for the first 6 cycles of this, we are just going to completely forget about this one, we don't care that it exists. After those 6 cycles, when we have something like 4, 3, 2, right? After 6 cycles we'll have 1, 4, 3, 2. Then at that point there is nothing like find the next thing bigger than 4, that is just not possible. So then you need to go to 1 and then find the fellow who is just bigger than 1 over here, and then put that and then sort the remaining and then so on. So right, so yeah, so just to kind of continue with this dry run, you will flip this, so you will get this. Then you will be like, okay, again flipping 4 doesn't make sense. Why? Because it's not sorted, right? 4 is bigger than 2. If it was sorted, you will just flip it to go to the next permutation. If it's not sorted, then you have to do a 3 cycle, some kind of a 3 element cycle. If that 3 element cycle is also completely finished, then you have to do the 4 element cycle, right? Do you understand the intuition? Like basically what you're doing is, you're doing the minimal kind of thing. You take this permutation, you start with 1, 2, 3, 4, then to go to the next one you just have to flip the last 2. Then if the last 2 are already flipped, then you now have to perform a 3 element process. Then 3 element like that till 6. Then if all the 3 element is done, you do a 4 element thing. Then you do 3 element until 6 of that are done, and then you do another 4 element, and then 3, 4, and then so on. And then once you've exhausted all the 4 element stuff, you'll do the 5 element stuff. Then after you exhaust all that, you do the 6 element stuff. And then if your whole fellow's length itself is just 6, then if you reach the bottom of it, you just reverse the whole array, right? Okay. Actually, I don't know why I'm returning this. I don't need to. I'm just going to do it in place. Okay, so let's now code up this logic. Yeah. So now what you're doing is you're going to start from, you're going to first look at the last 2, right? So the way I'll do that is, let's just say something like int n is arr.size. So you'll start at n minus 2, j greater than what am I doing? Greater than minus 1, minus j, right? So you're coming from the last, and you will be comparing arr of j with arr of j plus 1. Now we want, if it is sorted, then we flip it, right? So essentially we need to check if arr of j is smaller than arr of j plus 1. If it is, that means we have kind of found the troublesome guy. Like we have found the size of the cycle that we have to perform. Like, do you understand? So like in this case, the cycle that so okay, let's start with here. Let's start with here. So here directly you can see that these two itself are already sorted. So the size of the thing that you have to perform is going to be 2, and like this is the index at which you have the problem, right? So similarly, if you look at this, this is not sorted, so you can't flip it again. So you have to go to the next one, and this is sorted. So here is where you have to keep your index. Essentially, we want it to be not sorted until you have it is not sorted. Like, do you understand what I'm saying? Then you need to just do a swap and then like reverse. Sort the remaining elements. Okay. So after finding this, what do you have to do? So that means you have found the size of the cycle you have to perform. Then from j plus 1 to n, like this is j, this will be your index j. Then from j plus 1 to the end of your array, you need to find the fellow who is just bigger than 2. So let's call that index as next successor. I hope that's the correct spelling. And let's say it's j plus 1, okay. What you need to do is find the fellow who is just bigger than 2. In this case it's 2. Just bigger than 2, but not too big, like the one who is just bigger. So for that, what I'll do is, I will start again at, and the thing that we can exploit is, if you just look at this for example, everything here will be in the reverse order, will be unsorted, like that's the condition that we are using here, right? So what we can do is, if you want to find the guy who is just bigger, you start from the end till I greater than j minus I, and the condition that you have to look for is, if array at I is bigger than array at j, then your next successor will be I, and then you can break. Okay. Now once you have your next successor, which is the element that you must have, essentially you must now do a swap. So std swap arr at j will swap with arr at next successor. Then after that swap is done, you now need to sort the remaining fellows, right? Now if you look at that, it's already going to be in descending order. So if you want to sort it, it's just reversing it. So for that, I'm just going to write a function called indexed reverse, which is going to take std vector of integers called array and an int low. Int low basically tells from which index till the end you have to perform the reverse. So then let's define something like int I, which is going to start at low. Then while this is just a normal reverse function, it's just I'm modifying it slightly, plus arr dot size by 2. So while it is smaller, what you have to do? You need to do std swap of arr at I with arr at, okay, I'm using arr dot size twice, so I'm just going to define it as a variable, arr dot size. This will be n minus I minus 1. But this would be like the mirror element. We need to offset it also by low, so you need to do a plus low, n minus I minus 1 plus low. That's it. So let's just do an indexed reverse. So indexed reverse of this from j plus 1 onwards, and then simply return out of the function. If you never do this, that means if you never reach this condition, that means that's the last element of your cycle. So you have to perform an index reverse from 0. And yeah, that's it. This was the way I approached the next permutation problem. So let's see if this works. std let's maybe do this. Let me make a print-vec function. Okay, so then here I will say next permutation v1 arr print by krr, so we can see the next permutation. So is that correct? 1 2, yeah, that's the next permutation. If I make this 4 2, then what should happen? We should get 1 4 2 3. Some problem is there. Sorry. Okay. Oh, I forgot to increment I. Lol. Yeah, now it should be fine, I guess. 1 4 2 3 is correct. Yeah. For 3, oh sorry, correct only. So yeah, that's it. That was my logic for the next permutation problem. I mean, I think in terms of the program, it's the same as the striver one. But yeah, I felt like this was a different way of thinking about the problem. I don't know if I explained it too well, but yeah, I think hopefully you got the crux of what I'm trying to say. It is very similar to finding that prefix, the largest possible prefix match, but like I came to the same logic with a different thought process. So yeah, cool, bye. I mean, even if I didn't explain it well, I hope when I watch this back in the future, I'll understand myself. So that's the point of good code, I guess. Maybe I should write some comments. Yeah, okay, bye bye.